Hello, Maurieo! This video is a response to my previous video on the resection, where I've been asked to explain the TIENSTRA resection spreadsheet that I used to solve the TIENSTRA equation. So as I say, here is my response to those people that asked to have a little more depth around the spreadsheet itself. Alright, so here we are, and what I've done here is I've put my diagram and the formula here from my previous recording. I'm hoping that this will be quite visible and easy to see. And here we have A, B and C here, and alpha, beta and gamma all in the correct relationship. Remember, that relationship is quite important. So alpha opposite A, beta opposite B, gamma opposite C. So we had all those worked out and sorted, so then it came down to using this formula here. Now looking at the formula, first of all we can see that it relies quite heavily on the cotangent here, and it needs the cotangent of all of those angles and also the northing and easting of all of the 3 points. So here we are is my spreadsheet, and this is what I just decided to do as I thought it would be an easy way to calculate it out. I've got A, B and C down here, the angles at each of those, as well as the coordinates, the northing and easting of those. Also here we have alpha, beta and gamma, and the degrees, minutes and seconds for those. And then K1, K2 and K3, which will be calculated out here from the cotangents from each of the angles as I've calculated here. Now the thing with Excel is, one, it doesn't deal very easily or readily with angles in the degrees, minutes and seconds format. So what I've chosen to do is to put them in individually. So I've got 72 degrees, 0 minutes, 41 seconds in there. And furthermore, Excel deals in radians, not degrees, minutes and seconds. So first of all we need to get our degrees, minutes and seconds and to put them in decimal degrees and then convert those to radians. So that's what I've done here. Here's B4, which is the 72 degrees, plus C4, which is the 0 minutes, divided by 60 in this case, divided by 60 to make that a decimal, and then plus D4, 41 here, that is divided by 3,600, 60 minutes times 60 seconds. So that will give us, adding those three together, will give us the decimal degrees. Now we know that the full circle, a full circle is 360 degrees, and that is 2 pi radians. So what we do is we work out what fraction 72 degrees, 0 minutes, 41 seconds is of 360. So we've put that over 360, and then we simply multiply that by 2 and by pi, and that converts each of these here into radians. So that's that little bit explained. The next thing is to do the cotangent. So we've got the radians here, and the cotangent is just 1 over the tangent. So here I've got 1 divided by the tan of E4, 1 tan E4 there, and that will give us the cotangent of each of these angles, as you can see here, all the way down here. So the next step was then to calculate K1, K2 and K3. And looking over here, we can see that 1 over K1 is cotangent A minus cotangent alpha. So what I've done here is I've gone 1 over the F4 minus F7. So F4 here minus F7 here, that will give us K1, and then this here again K2, and this here K3. So if 1 over K1 equals cotangent A minus cotangent alpha, K1 will equal 1 over that, which is what I've done here. Again, just to reiterate that, so it's 1, just worked it out there. So then that's got all the information that we need. We've got our K1, K2, K3, our northing and easting. It just remains then to put in our formula here. Now what I've done here is I've put the formula in such a way so that I could transfer it over to the other one there by using the dollar signs are constant values there. So for instance here I have got first up, if we just push the F2 button, that tells us where everything is. So first of all I've got F10, which is K1, and I'm going to hold that, and that's times G4, which is A there, and that's unfettered. So when I copy this particular cell one to the left, the ones with the dollar signs will stay there, and the G4 will convert to the easting and become H4, which we'll have a look at the moment. So there's that, plus F11, which is K2 times G5 there, plus F12 here, which is K3 times G6, and then I've put that in a bracket, and then that's divided by K1 plus K2 plus K3 here, and that gives us our northing. And then I can quite simply with the spreadsheet just copy that equation across to here, which is what I've done, and again you'll see that it's F10 and it's times H4 there, H5, H6, and there you are. That calculates very nicely the northing and easting of Q using the TIENSTRA resection calculation, and I've just set up this nifty little spreadsheet here to do that. So obviously if you have different values in here, it's just a matter of putting the correct values in the spreadsheet, and straight away it'll calculate out your northing and easting for you. Now that would be quite handy, because where you've got, say, you've observed more than 3 stations, that will give you a number of combinations of those of 3, and each one will give you a solution for Q, which, provided they're all within acceptable limits, you can take the mean value of, and get a good value for Q to start your survey off on. So there you are. For those of you that were wondering or wanted more detail about my spreadsheet, there you go. Fill your boots.